Good morning, everyone, and welcome to our presentation on site preparation and soil compaction, based on SBC 304. Today, we'll walk through the essential steps to ensure a solid foundation for construction projects. We'll cover site clearing, soil compaction techniques, laying aggregate, performing quality tests, and pest control measures. I'm excited to share these key procedures with you, so let's get started and explore how to prepare a site effectively for successful building. Now, let's look at the blinding and anti-termite treatment process. First, we start by placing a 200-micron PE sheet, which acts as a moisture barrier and helps prevent termite entry. Next, we pour a layer of plain concrete blinding, about 7 centimeters thick, using a mix ratio of 1:4:8. This layer provides a solid, level surface and protects the underlying ground. After that, we apply the termiticide carefully over the blinding. It's important to allow this treatment to cure for at least 24 hours to ensure its effectiveness. Finally, before we move on to waterproofing, we need to verify the levels of the blinding and treatment layers, making sure everything is accurately aligned and stable. This step is crucial to ensure the durability and safety of the entire structure. Now, let's talk about the foundation rebar and waterproofing, based on SBC 30472. First, we need to apply a primer followed by 2 layers of form bitumen waterproofing material. This ensures a solid moisture barrier to protect the structure. It's also crucial to maintain at least 75 millimeters of rebar cover. This cover protects the reinforcement from corrosion and fire, which is vital for the durability of the foundation. When pouring the concrete, we should aim for a strength of 25 MPa with a slump between 75 and 100 millimeters. This range helps in achieving good workability and compaction. Finally, proper curing is essential, so we need to keep the concrete moist for at least 7 days. This process allows the concrete to develop its full strength and minimizes the risk of cracks. All these steps are interconnected. They ensure the foundation's strength, durability, and waterproofing, which are fundamental to the overall integrity of the structure. When working with columns and beams according to ACI 318 standards, there are a few key points to keep in mind. First, it's essential to properly align the formwork and make sure everything is perfectly plumb. This helps ensure the structural integrity and proper load transfer. Next, when pouring concrete, do it continuously to avoid cold joints, and make sure to vibrate the concrete every 50 centimeters. Proper vibration helps eliminate air pockets and ensures good compaction. After pouring, the concrete needs to be cured for at least 7 days to develop adequate strength, so consistent moisture and temperature control are crucial during this period. Lastly, you can remove the forms after 48 hours, but always remember that the form removal time depends on the concrete mix and curing conditions. Keeping these steps in mind ties into our overall goal of achieving strong, durable, and safe structural elements. Now, let's talk about the key steps involved in working with slab and ground beams according to ACI 301. First, it's important to fix the rebar mesh after completing the MEP works. This ensures that the reinforcement is properly positioned before pouring concrete. Next, when pouring the concrete, we aim for a slump of about 75 to 100 millimeters. Maintaining this slump range helps achieve the right consistency for compaction and finishing. Speaking of which, after pouring, we need to vibrate the concrete thoroughly to eliminate air pockets, and then finish the surface using a power trowel for a smooth, even finish. Curing is a crucial part of the process. We typically cure the concrete for 14 days to ensure proper strength development. During this period, we also test cube samples at 7 and 28 days to verify that the concrete meets the required strength specifications. All these steps are vital for ensuring the structural integrity and durability of the slab and ground beams, which are foundational elements in our overall construction project. Now let's talk about masonry and blockwork, based on SBC 304 standards. When laying bricks or blocks, it's important to use a 1:4 mortar mix, which means 1 part cement to 4 parts sand, ensuring a strong bond. The mortar joints should be no thicker than 10 millimeters to maintain quality and consistency. To enhance stability, we need to interlock every 3 courses, which helps distribute loads and prevents sliding. Additionally, at junctions, it's recommended to use L-bars, which reinforce connections and add to the overall strength of the wall. When casting lintels, make sure they are at least 15 centimeters thick, and remember, curing is crucial. Allow at least 3 days for proper curing to achieve the desired strength. These key points are essential for building durable, safe masonry structures that meet the standards and integrate well into the overall construction process. Now, let's talk about drainage and underground piping, based on SBC 701. When laying PVC or UPVC pipes, it's important to place them on a sand bed that's about 10 to 15 centimeters deep. This helps ensure stability and proper support for the pipes. Maintaining a slope of 1 to 2% is crucial for effective flow, so water moves smoothly without pooling or backing up. After installation, conducting a leak test for about 30 minutes allows us to verify that everything is sealed properly and working as intended. Lastly, for manholes, keeping them no more than 1.5 meters apart is key to ensuring easy access for inspection and maintenance. These points are essential in creating reliable and efficient drainage systems that support the overall integrity of the project. Now, let's take a closer look at the construction of the underground water tank, referencing standards SBC 305, 703, and ACI 350. First, we start with creating a compact base, which is essential to ensure stability. We then pour a 10-centimeter layer of blinding concrete to smooth out the surface and prevent contamination. Next, we apply a primer, followed by 2 layers of SBS membrane, each 4 millimeters thick, to provide a strong waterproof barrier. After that, we pour the waterproof concrete with a compressive strength of 35 MPa, ensuring durability and leak resistance. A critical step is fixing the PVC water stop, which should be 200 millimeters wide, to prevent water ingress at joints. Once everything is in place, we conduct a leak test lasting 72 hours to verify the integrity of the tank. Only after successful testing do we proceed with backfilling, making sure to protect the structure during this process. These steps are vital to guarantee the waterproofing and longevity of the underground tank, aligning with our overall goal of creating a reliable and durable water storage solution. In summary, it's essential to follow the SBC standards 304, 305, 701, and 703 throughout the project. These standards ensure quality and consistency in our work. We must perform all the necessary tests, including FDT, slump, cube tests, leak testing, and waterproofing checks, to verify that everything meets the required specifications. Remember, all concrete should be cured for at least 7 days to achieve the desired strength and durability. When working with tanks, always use potable grade materials to ensure safety and compliance. Finally, maintaining thorough inspection reports and adhering to safety protocols as outlined in SBC 301 is crucial for the success and safety of the project. These key points tie everything together, reinforcing our commitment to quality, safety, and standards compliance in every phase of the construction process.